Welcome to Peninsula Seniors Out and About. We're at the Western Museum of Flight in Torrance. Let's go see what Cindy has for us today.
Welcome everyone to the Western Museum of Flight. I'm Cindy Maka, the director. For many years, the Northrop Grumman Model Shop was admired throughout the industry for the high fidelity representations they produced of some of the most advanced and exotic aerodynamic achievements in the world of aerospace technology. The direction, guidance, and principal expertise of that operation was embodied in one very special individual who happens to be an accomplished and authoritative historian. We are privileged today to have that exceptional individual with us. Ladies and gentlemen, it is my pleasure to present to you our guest speaker for the month, Mr. Tony Chong.
As Cindy said, my name is Tony Chong. I did run a display model shop the last few years of my career. I had a 30-year career at Northrop Grumman, originally Northrop, so I'm a heritage Northrop guy. A lot of you here are. I see a lot of familiar faces, and it's good to see you. One of the things that I had promised myself to do, and many of you, because I opened my mouth and said this, decided that they should bug me about it. Chad, yes, you're one of them. Is to write this book, because I developed an interest in aviation. I was fortunate enough to go back to college. I went to Cal State Los Angeles, and I wanted to focus on aerospace because I was in the history program. And I met a fellow by the name of John Reynolds who ran the tech library at Northrop, and this was in the early 1990s, and I got to see some of the stuff that Northrop did, and it just really inspired me to want to pursue it further. So this book is essentially the result of that. I do want to mention that this is Jack Northrop here. Jack Northrop founded the last company to bear his name, Northrop Aircraft Incorporated, on 7 March 1939. And of course, he became well known for radical designs. You can see him here with a picture of the YB-49. Note the lack of the vertical tail fins on this. This was an early iteration of the YB-49. I am not going to give the history of the book. If you want the history and stuff in it, buy the book. What I am going to tell you about is some of the things that I alluded to in the book, which is the design philosophies as they transpired. This is part one of 2 parts. This is a long exposition and exploration of Northrop designs. I couldn't fit it into 1 hour. However, there will be a part 2 sometime down the road. What we will cover in this part are the design themes. As I mentioned, we're going to look at the evolution of design philosophy. So we'll talk about the Northrop tail, we'll talk about flying wings, both pure wings, which Jack Northrop's best known for, and the wing body designs, some of the air-breathing missiles, and supersonic evolution. Part 2 will cover the lightweight fighter evolution, advanced tactical fighter studies, both white and black world, at least the stuff in the black world we can talk about, the attack configurations, both Air Force and Navy, VSTOL and the road to the JSF, Joint Strike Fighter, ISR, intelligence, surveillance, reconnaissance platforms, space, miscellaneous designs, mainly the cool stuff that I couldn't fit in anywhere else, and then to wrap up the whole thing. But that is in part 2. As I mentioned, we will talk about the design philosophy. Each company, for those of you who follow aerospace, you can perceive design philosophies. They talk about the Douglas tail. They talk about some of the other things that are inherent in the design. And the reason is when designers figure something out, they try to utilize it as much as they possibly can. Why reinvent the wheel? We've got this perfectly good horizontal and vertical tail system. Let's plug it into the next aircraft. We'll size it up, we'll size it down. So that's how a lot of this stuff evolves. And then, of course, advances in aerospace technology leads to different things. So this is what we're going to talk about. One note, oftentimes propulsion trails the airframe, which is why I've had a lot of structures and configuration engineers always say, well, it's all propulsion's fault. Well, yes, but no. Propulsion, there's a lot of things to take into consideration, metallurgy, power, all of that sort of stuff. So it's really a fascinating evolution of the power plant as well as the airframe. So let's get right to it. We'll talk about the Northrop tail. When Jack Northrop formed his new company, he had already had a company in partnership with Douglas. It was a wholly owned subsidiary to the Douglas Aircraft Company. It was called Northrop Corporation, and it was in El Segundo. They developed a whole line of aircraft there, and when he left in January of 1938, he, of course, had all of his designs in his head, and so when he started the new company, the first drawing that they came up with was basically an iteration on his Gamma series of attack aircraft. The Northrop Gamma was a well-known aircraft that he designed in 1932, and it evolved into attack variations. Some were sold to China, some were sold to Peru. Well, he, of course, had this ready-made design, so the very first Northrop Aircraft Incorporated drawing is of this version called the 8A. Now, there was a Douglas 8, Douglas Bomber 8, which was an iteration of the Gamma. That went on with Ed Heinemann, good catch. That went on with Ed Heinemann and became the Douglas SBD Dauntless. This one, as you can see, is very much similar to the A-17, and then it evolved into the N3. And you can see the N3 on the right-hand side there, the 3 view for that. Note the tail. It's much more rounded. The canopies are much more streamlined. The airplane is a much more refined concept than the 8A. So you go on with that, and you look at the N3PB, which was basically a patrol bomber float plane version of the N3, retained the tail. He decided to do a twin-engine fighter, a night fighter version, which retained that same tail, called the P-61, the Black Widow. The P-61 went further iterations. They cut down the upper deck, made it into an escort fighter and a reconnaissance fighter. The lower right one is of the N-21, which was supposed to be the P-61F, which was an interdiction fighter. It was meant to go in and do strikes on enemy targets during the night. It was basically a night intruder. So you notice the tail is retained. Because you have a design that works, you of course try to expand that design to fit all possible niches around. Light cargo, there was a need for it during World War II, so of course you make the fuselage or the crew nacelle section on the P-61. You see the upper left drawing there. You make that into a cargo variant. So there you have a cargo called the N-15, tricycle landing gear, just a little bit shorter than a standard P-61 because the nose doesn't have the radar, but it could carry cargo. That tail then migrated to the N-23. The N-23, the 3 view on the right-hand side there, that is a rough field passenger aircraft that Northrop developed after the war. He was convinced by Lamont Cohue and Jack Fry. Cohue was his general manager, Jack Fry was head of TWA, and they convinced him that a rough field, short hauler airliner was necessary for the post-war era, never mind the fact that the Army is going to release all of these surplus C-47s and C-54s to the industry. Jack Northrop sort of had hesitations, remembering the debacle that the Lockheed brothers went through after the First World War when they developed the S-1 and were just clobbered by all the surplus aircraft coming out, said, well, you're running the business side, go ahead. Of course, the N-23 had 0 sales. But it had the Northrop tail, at least in the early iterations. Later iterations, that tail started to evolve. You can see here it evolved into the N-32, which eventually became the YC-125 Raider. There's a picture of it right up here that one of the gentlemen in the audience brought in who worked on it during his Northrop career. This retained the tail, but it was a twin boom version, sort of a cross between the N-23 and the P-61. So again, you see how the design philosophies, working with what you know, expanding upon what you know, evolves into something like this. But let's talk about what really interests people, the flying wings. The Douglas 9, Project 9, of which this is an illustration done expressly for the book by aviation artist Craig Codera, who did 3 illustrations in the book. This was an idea that Jack Northrop had while with Northrop Corporation in El Segundo in 1937. He convinced the board of directors of Douglas, because it was a Douglas subsidiary, to actually begin development of this aircraft. Now, Northrop leaves in January of 1938, but they go ahead and they do a wind tunnel model and wind tunnel tests on the vehicle. There are photos that have popped up that show the Project 9 that was done by Ed Heinemann, who succeeded Jack Northrop as the chief engineer for that company. Heinemann did the tests, was never enthralled with the idea of a flying wing, so they did not pursue a pure flying wing. This is actually not a pure flying wing, it's a wing body, but it's close enough. Note the end plates on the wings on this one for lateral control. Well, when Jack Northrop starts his company, one of the first designs that they want to do is pure flying wing and a pure flying wing research program. So the designs evolved for a twin-engine medium bomber. You can see on the left the early version of the N1, and on the right a later version of the N1. The early version with that big greenhouse-shaped canopy that essentially conformed to the airfoil of the wing. It housed 7 crewmen. It had gunners and pop-up turrets, and it was a pretty impressive-looking airplane. The later, late N1 designs also had gunners. One of the interesting features, which is hard to see in the drawing here, but you can see it better in the book, is that there were guns. There were gunners on the, if you look at the early design on the front view, you can see 2 guys sitting outboard of the pilot and the co-pilot and the bombardier. Those guys were gunners firing fixed forward guns. Whatever. They went to turrets on the later version. The early version, the guys in the turrets would actually walk out and sit into the turrets out there. You can see the guys sitting out there. So it was a pretty far out design. But you notice that it is a pure wing and it has the bent wingtips, the droop wingtips. That was a design feature that was thought to give added stability to the aircraft. They decided to do a manned proof of concept vehicle called the N1M. John Northrop, the son of Jack Northrop, told me a story once about how they went up to Moy Stevens' house, up in a cabin up in the mountains, and it was a stormy day, so they spent the evening making paper airplane models of flying wings and flying them and drooping the tips down or drooping the tips up to see which was more stable. And he said, well, the upward sweep on the wing was actually more stable. That was my design, but they decided to go with the downward droop. So that's John H. Northrop's story. So they did test it. You can see there. What is also of interest, note the kink in the leading edge. The N1M was designed so that they could adjust the wings angle, the sweep on the ground. They had different stations they could adjust it to, and the wing droop could be adjusted to reflect varying degrees of droop. What eventually came out of this was that a straight leading edge and no droop at all to the wingtips was perfectly stable, or as stable as the other designs. So you will see that evolution away from the droop wingtips. But not before they proposed the N9, which would have been an intercontinental bomber, 4-engine intercontinental bomber with drooped wingtips. Now, this particular design had a wingspan of 165 feet. Remember that. That'll come up later. What it evolved into was a unkinked, no droop on the wing, 172-foot span flying wing. This is the XB-35 on an early flight. 8-bladed contra-rotating propellers that gave the program fits. They were government-supplied parts, which means that the government mandated which engines the company would use, which subsystems the company would use. So your propellers, your propeller governors, your shafts, and your engines were all government-issued, in this case from Pratt & Whitney. They were R4360 major, WASP majors. They had terrible vibration problems. Even before the aircraft was built, with the test stands and everything, they knew they were going to have problems. They decided that perhaps a jet engine version would be better, but not before they decided to do a proof of concept test like they did on the N1 with the N9M. And the N9M was a 1/3 subscale model of the B-35. Note that it does not have the drooped wingtips. What it did have, and you can see on the drawing on the right there, it had the clamshell rudders. They eventually went to split trailing edge rudders and did away with the clamshells. But that design influenced the N10, which is the three-view drawing on the right. The N10 is an interesting aircraft because there's virtually nothing about the N10 out there. Even the official Northrop listing for the N10 describes it as a turbodyne engine project. So this N10 was a very quickly stillborn cargo version of the Flying Wing, twin-engine cargo carrier that died, and the number was reassigned to the turbodyne engine. Well, as I mentioned, they decided as early as 1944 to try to retrofit the aircraft with jet engines, and they picked 8 GE-designed, Allison-built J-35 engines. They used the same basic airframe, which caused some problems. Jack Northrop requested flight restrictions on the aircraft because the airframe wasn't stressed for the higher speeds and loads. The Air Force said, no, it's just a proof of concept. We don't need to worry about that. Yeah, we all know what happened with that. The first flight was 21 October 1947. It was only 2 months behind schedule, whereas the piston engine Flying Wing was several years behind schedule. That was not entirely Northrop's fault. Because Britain prevailed during the Battle of Britain, we didn't need an intercontinental range bombers. We were able to do the war with our standard bombers at the time, the B-17, the B-24, using Britain as a base. If Britain had lost, that would have been a different story, and more emphasis would have been placed on the intercontinental bomber. So that got pushed to the back burner. Post-war, you saw both aircraft fly. The jet-powered version was immediately, noticeably better in vibration and roughness of ride than the B-35. So it was a superior aircraft in that regard. What was the problem with it was those jet engines, those early jet engines, were gas guzzlers. So now your long-range heavy bomber now has much curtailed range, less payload because you had to carry more fuel, and in effect, the Army Air Force and later the U.S. Air Force downgraded the B-49 from a heavy bomber to a medium bomber. And when you're a medium bomber, that means your competition is not the B-36, as many people think, it's the B-47. Which is 100 miles an hour faster, could carry the nuclear weapons of the day, and could carry less crew. So, hands down, B-47. But not before Northrop decided to pitch more versions of the wing. They quickly realized that it wasn't going to be a bomber, so they proposed it as a reconnaissance bomber, strategic reconnaissance. We were desperately concerned about what the Soviets were doing, and we needed reconnaissance aircraft to go and find out. And so Northrop proposed several versions of a reconnaissance flying wing, the RB-49. Now you'll note the nomenclature along the sides there, which makes it very confusing for a lot of people as to what the heck we're talking about. This is the basic N-37, but you have an N-37, N-37A, and an N-37B. You can see on the right-hand side of the drawings there, the nomenclature describing each aircraft. That in turn became the RB-49A, B, and C. So there's a lot of conflict on what terminology you're using. It can get confusing really quickly. The initial concept was the RB-49A would be a rush interim job. You get that done quickly. It originally had the 8 engines that the YB-49 had. They quickly decided that, we're upgrading it to J-47s. You can't fit 4 J-47s in the same space that you had 4 J-35s, so let's just put 3 there and 2 on pods. So three on each side and 1 on pods on each side. The middle version shows 6 Westinghouse J-40s. So you do away with the 8 J-47s and you put in 6 engines. The bottom version shows Northrop's Turbodyne. Turbodyne engines was essentially a turboprop with 10,000 shaft horsepower per engine. It was decided that the B-49A would have inadequate range. This is the Air Force deciding this in late 1948. The RB-49 was slower than the RB-47. And by the time the RB-49C would come online, which would be faster, they were projecting that the RB-52 would be flying. So the result was they canceled the program. And so the stop work order came through on 11 January 1949, which essentially killed the large flying wings. But not before Northrop had done a couple of other iterations. The N-39 was taking YB-35s. Now remember when they first started doing the original XB-35s, they were going to do YB-35s as the follow-on, and then B-35s would be built by Martin in Omaha, and they had an order for 200 B-35s, which was canceled by the end of the war. But they said, well, we still got these shells. Well, what are we going to do with them? So they said, okay, we'll take 2 and convert them to photo reconnaissance trainers. And so you see there were different iterations. The top view up there shows 2 in the wing on each side and 2 potted engines on each side, so a total of 8 engines. The bottom view shows a 6-engine variant of the aircraft. That later on would become the base line design for the YRB-49. The N-40 was proposed by Northrop to address the shortcomings of the YB-49. Note that it's got 6 engines. They are Westinghouse J-40s, each with 7,500 pounds of thrust. It had offset nose turrets and a dorsal tail turret. You can see on the top drawing, you can see the little turret just to the right of the canopy there. It could either be a 2-gun 50 caliber or a 4-gun 50 caliber, and the aft tail, I think they're switching to 20 millimeters. It also carried the AN/APQ-24 bombing navigation system. This would become standard on later versions, or was going to be standard on later versions of the wing. It also had the Honeywell E7 autopilot, which would have addressed all of the stability concerns that were given up in the YB-49 program. It was a little bit too late, though. The one big wing that did fly after 1949, other than the remaining XB-35, which suffered a landing or a taxi accident at Edwards when the nose gear shimmied and the airplane just collapsed on its gear and burned up. This was the YRB-49, also known as the N-41. This is it taking off from Hawthorne. It only had a few flights. The last flight was the only one done by an Air Force crew, and that was to ferry it from Edwards Air Force Base to Ontario, where it sat out in at the end of the Northrop facility that was out there amid the vines of the grapes, and was eventually scrapped by 1 December 1953. Other pure wing designs, there was the Turbodyne test bed. This was the N-45, also known as the EB-35B. They had a couple of other designations. There was such a rapid amount of change in that time frame that it's difficult to keep up with the alphabet soup. But this is basically 4 J-35s and 2 XT-37, which was the Northrop Hendy Turbodyne engine, again with the 10,000 shaft horsepower engines. Now, the drawing in the upper left shows only one Turbodyne, because what they originally decided they were going to do is that they were going to outfit the aircraft originally with one Turbodyne and do some flight tests, and then add the other Turbodyne and finish up the testing. So the drawing on the bottom, the 3-view on the bottom, shows what a fully outfitted EB-35 would look like, and note the intakes that protrude from the leading edge for the Turbodyne engines. I'm not entirely sure that I have the nomenclature right on this, but I arbitrarily decided that the N-46 and N-47 were likely these designs. They match up, correspond with what I read in the log and with what I saw on the dates and whatnot. So this is my go at it. If somebody can prove me wrong, I'd love to hear it. The N-46 was an unusual design because I didn't realize this until I started the research. Northrop also did a turbojet version of the Turbodyne. So this is the turbojet-powered Turbodyne for a flying wing. 6 Turbodyne engines. The bottom one shows the Turbodyne with 2 Turbodyne turboprops, but with supersonic propellers, which means they're the short, stubby three-bladed, or actually six-bladed contra-rotating propellers here. Now, if you bear in mind, this is around the time that the Republic XF-84H was flying, called the Thunder Screech, for good reason, because the harmonics created by those contra-rotating supersonic propellers literally induced nausea in the ground crew. You can imagine what two of these things would do. People would start bleeding from the ears. There was an airliner version of the Flying Wing, short-lived. Northrop even produced a film, a Hollywood film company came in and did a version showing the wonders of a pure Flying Wing airliner. What was amazing to me was the luxury appointments of the people flying airplanes. It used to be a much bigger deal than it is today, cattle car heaven. Back in the day, luxurious rooms, a woman standing at the leading edge of the wing looking out the window at the countryside, people with the cocktail lounge and where the tail stinger used to be, enjoying the scenery, having cocktails. No. So that didn't happen. In 1979, this is after a drought, because once Jack Northrop retired, Edgar Schmood, who came in and became vice president of engineering and wanted to put his stamp on the program, absolutely made Flying Wings and Jack Northrop's name verboten in advanced design, or preliminary design in those days. So it was not until the late 1970s, 1979 to be specific, that Northrop was asked to look at bombers again. And it was specifically for a low observable. Now, Northrop at the time said, we're not a bomber house, we're a fighter house. But Tom Jones had a phone call for William Perry, who was then director of Defense Research and Engineering a few years previous, and Perry essentially told Jones, if anything concerning low observables comes up, Northrop, I want you to bid on it. So Tom Jones essentially told his staff, we're going to bid on this program, and we're going to have an answer in 6 weeks. So Cashin and the other guys sort of scratch their heads and go, well, okay. They had already toyed around with some idea, but Irv Wallen and John Cashin then set to work, and they quickly realized that a Flying Wing was a very low observable platform. Now, the initial drawing for the ATB, as it was known, the Advanced Technology Bomber, was 165 feet. Remember, the bent wing XB-35, 165 feet. Once they refined their design, it came in at 172 feet, the same span as the B-35. And they're going, wow, Jack Northrop, they must have had something on the ball back then. So the 172-foot span aircraft was the winning design. Now that photo of the model on the upper left is the winning design. This is the design that Jack Northrop saw when he visited the 360 building at Hawthorne. It wasn't at Pico, and he wasn't in a wheelchair, unable to speak, and he wasn't presented a model of the serrated tail B-2. No, this was the model he saw, and he stood and he took pictures with the engineers at the time, and he basically told them, now I know why God has kept me alive for so long. But he was able to speak, unlike a lot of this malarkey you see on the internet. I should know because a month later he spoke at IPMS Space Park, and he spoke very well. Yes, he had Parkinson's disease, but he certainly made his opinions known. So the B-2 came after that. So that is essentially the resurrection of the Flying Wing as far as Northrop is concerned. It didn't end with Air Force. It also went to the Navy Advanced Tactical Aircraft Program. Now, the problem with this program, and this is a program that we were teamed with Grumman and with Vought, a smaller aircraft, we decided to make it basically a baby B-2. And you can see in the model photo on the upper left, it conforms pretty close to the original ATB concept. But what we didn't like about the program is that it was a fixed price. We had already been stuck with a fixed price on TSAM, and they were eating our lunch, and a couple of other programs were fixed price, and Tom Jones says, absolutely not. And the Navy insisted that we respond, so we came back with a bid that was deemed unresponsive. In other words, we told them what we thought it would cost, and they said, well, that's not what we want. So they said, okay, well, that was your best and final. Let's go with a really best and final. And we came back with another unresponsive bid. And so McDonnell Douglas and General Dynamics won the program that became the A-12, and we know how wonderful that airplane turned out. The drawing on the bottom right is a later iteration. Once the A-12 was canceled, the Navy still needed an attack aircraft, and so the contractors, and Northrop among them, came back with some proposals. This proposal, with the serrated edges looking like a baby B-2 for real, was called the signature-driven design, and we'll see some of the other designs later. So we're going to go on to the wing body designs, and that was probably epitomized initially by the N2 or the XP-56, Black Bullet. Now, if you notice on the three-view drawing on the right, if you look at the side views, the side view on the left with the short stubby tail was one of the original configurations. In fact, that was the configuration of the first XP-56 that was built. The photograph on the right is of the second version. The first one had stability problems. It had that terrible taxi accident where the tire blew out and you see the airplane cartwheeling down the way, and the pilot was thrown out and he survived. And so they decided to lengthen the tail. The drawing on the right, the side view drawing, that's the middle drawing, or the drawing on the right of the side view, that is a jet-powered version. They had toyed around with the idea of putting a jet in it. So they were not very happy with the performance. This wasn't one of the best designs, but that started the idea of the wing and body. So you can see how the wing and body and a pure wing are starting to compete with each other for some of these types of roles that Northrop was looking at. The N-12, this was a proof of concept for a proposed fighter, which became the XP-79. The XP-79A, you can see in that drawing on the right, the pilot was prone. Note the guns. There's a story going around that this was designed to ram enemy aircraft. All of the specs show that it was to shoot them down with guns. It was magnesium, and so people said, well, it's a hard metal. It must be used to cut off the tails of enemy airplanes. The funny thing is that Gary Pape, who used to work at the museum here, put forth the idea that that whole concept was really just a brainstorm from somebody at Wright Field. And in fact, when the XP-79 was released to the public, in terms of it was announced to the public several months after it crashed on its maiden flight, the Northrop News and the Northrop PR release took their cues from Wright Field and called it an airplane used to ram enemy aircraft. And then Jack Northrop, in his oral history, says the same thing. So it's like, oh, well, if Wright Field says that, it must be true. So that's how these things get started. But nowhere in the official literature can you find anything that states that this aircraft was supposed to ram something. It'd be ludicrous. Contrary to popular thought, and something that I learned doing this, is that the XP-79 did not die with that crash. Now, William Sears, in his autobiography, is adamant in saying that the airplane would have worked. What happened to Harry Crosby is that he got into a low altitude and he stalled to the right, and he did not recognize that he was going into a stall. If he had recognized the symptoms, he could have recovered, but he was also too low. So Sears is convinced that the XP-79 would have worked. Well, Northrop did not abandon the idea. They refined it. And so you come up with the XP-79Z. And you can see the version on the left is with the prone pilot, and the version on the right is with a seated pilot. Now, they had both rocket and jet-powered versions of this. Bear this design in mind. It comes back. Northrop was competing for 3 programs post-war. The Air Force decided as early as 1945 they needed a new penetrator, they needed a new interceptor, and they needed a new night fighter. But they also ruled that only one company could win each of the programs. So Northrop submitted their designs. Very similar. The XP-79Z was essentially for both the penetrator and the interceptor. The aircraft here, the N-24, was the night fighter, and it was chosen. So that means the XP-79Z went away, and the N-24 became reality. Note the similarity of the drawing to the earlier XP-79Zs. This is a 3-engine version, 3 Westinghouse engines. And it's also a wing body. It's got the wing, no horizontals and a vertical, very similar in design to the XP-79Z. What they chose, the Air Force chose, was the more conventional design, which became the XP-89, later the XF-89. Note the tail. The original design, the tail was a little bit more rounded in the back. That Northrop tail succeeded all the way into the F-89. That wing body, the XP-79Z, did go on and become the foundation for the X-4. The X-4 was a transonic experimental aircraft used to study the effects of transonic conditions upon a semi-tailless wing. That design was also utilized for some other Northrop speculative designs, including the N-34, which was a notional concept. I don't know how real it was, but at least it was given an N number for a nuclear-powered bomber. Remember, there was a lot of studies in that time frame for nuclear-powered aircraft. Convair eventually won the design to build it. Boeing was in the hunt. Lockheed was in the hunt. We were there initially because we were also an engine manufacturer, as was Fairchild, so we were involved with the propulsion side, but we decided to toy around with the airframe side, and they chose that concept. Where the wing body really gets studied is in the N-31. Now, the N-31 was a follow-on to the B-49. And in this, Jack Northrop hoped to really take care of a lot of the problems that the B-49. The N-40 was really sort of interim, but this was really going to look at how they could make this thing better. This particular version, you had two types. You had 6 turbojets, including 2 turbojets on the wingtips. You had 2 turbine engine versions. So you can see the various styles there. The Turbodyne version is the drawing on the right. They also had 4-engine. They also had 6-engine concepts. They had a whole range of ideas for this aircraft, and it was one of the early multi-mission types. You could configure it for bomber, you could configure it for reconnaissance, you could configure it for escort fighter and make a mighty impressive escort fighter. This came relatively the same time. The N-55 was a patrol bomber, not in the sense of going out and looking for stuff. This was out to hunt and kill enemy bombers. If you look at that top view on the left-hand drawing, if you look at it very closely, you'll notice that it's carrying missiles in the wing roots. It could carry up to 44 MX-904 missiles. MX-904 eventually became the Hughes Falcon missile. It could carry 44 Falcon missiles. And note that the ones up there, if you look closely, there are several of them pointed aft. So not only could it shoot missiles forward, it could shoot them behind you. It was designed to go out, patrol over Canada, intercept Soviet bomber streams. Of course, the idea was that they would come over en masse, like in World War II, and you would just go out and you would take them out. That was the idea. This originally started in a configuration very similar to the B-49. You can see that it evolved away from it. It had Turbodyne and turbofan. You can see the 2 different drawings there. They also went to cargo variants. And you can see the wing body idea is very much inherent in this. They had systems to lift the cargo up into the bays by hoist. There wasn't much in the way of ramps. You can see that the left bottom drawing shows potted designs on the wing. So you go up and you attach these things and drop the cargo in and out. And it was sort of like precursor to the containerized cargo we have today. You could literally drop your cargo package onto a flatbed or onto a tractor trailer, and it would haul it off like a truck. The one on the right is kind of interesting because it had this massive center body with this kink in, so that there's this droop, a dihedral, or an anhedral, excuse me. And then you would slip it over a center pod, sort of like the B-58. And that center pod, in this particular instance, you can see the bombs in the back end of it. You had photo reconnaissance, you had troop carrier, you had hospital-type ship aircraft, and you had bomber variants of that. Not to be outdone, the Navy had their share of Northrop designs too. You'll note the 2 different types here, the very narrow, wide wing, and then the more blended wing body design. The left, very reminiscent of the Snark. We'll get to that in a minute. The right, very reminiscent of the early wing body designs. Very deliberate. Northrop was, again, working on the technology that it knew. Similar to, now these were both, incidentally, both designs for heavy attack aircraft. The program had been won by Douglas with what became the A-3D Sky Warrior, but this was for the USS United States, which was canceled in 1949. And so Northrop thought, oh, they've just canceled it. They're going to need a smaller airplane for the existing carriers. Let's come up with a bunch of designs. And then Douglas and Heinemann made the airplane work so that the Sky Warrior could work off existing carriers. So this idea went away. Similar to the large flying wings, there was this drought between Jack Northrop's retirement and the late 1970s, 1980s. You can see that this is a proposal that Northrop did, the N-381, for a multi-mission aircraft for the Navy. The Navy was looking in the mid-'80s or early '80s for an aircraft to replace the E-2, the S-3, the C-1, any range of aircraft that they were using both on land and on the carrier deck. The picture on the upper left is a drawing of a turbofan, unducted turbofan version with a single tail. The drawing on the lower right is a twin-tailed turbojet carrier aircraft. The Navy decided to stay with what it had, so this died. Wing body design did show up during the AX and AFX recompete after the A-12 was killed. This was probably one of my favorite designs. I kind of like this one, but this was called the balance base, balance between LO and performance. You'll see the performance-based design later. This always reminded me of an arrowhead. All right, let's go on to air-breathing missiles. Again, you will see the competition between pure wing and wing body designs in your guided missiles, your air-breathing missiles. The JB-1, of which the manned glider version is sitting over there in the other hangar, was essentially powered by two GE B-31 turbo superchargers modified to be turbojets. So they were given a new name, Type B-1 turbojet. The pods on either side of the inlet were bombs. That didn't do very well, so they went to a pulse jet, which is the N-16 JB-10, which is the photo on the right. You can see that the pulse jet is in the center there with the center inlet. The pulse jet essentially was done by Ford as the PJ-31. It was a copy. Talk about the other people copying our stuff. Well, we directly copied, reverse engineered a Fiesler pulse jet engine from their V-1 bomber unmanned aircraft. So that's how we got our pulse jet initially. And the JB-10 was that design. We took that basic concept and threw a turbojet in it. This is the N-18. And you can see it's bigger. It's got more of a wing body configuration and a little vertical there. It's not a big step to go from that and to stretch it to come up with the N-25, which is the drawing on the right. The N-25 was built for an Air Force requirement for an intercontinental range cruise missile. And this is back in just post-war, 1945, 46 is when they first started developing this, and the N-25 eventually started flying at about 1949. But you can see it is still technically a wing body design. There's no horizontal tails, there's not really much in the way of control surfaces back there. It was all in the wing and the body. That in turn led to the Super Snark, because the N-25 was the Snark. The Super Snark, which eventually just became Snark, was a much bigger version because the Air Force realized that they needed to increase the range, they needed to increase the speed, they needed to increase the payload. Requirement creep. We're all familiar with that. So here we go with the N-69. The early versions had Allison engines, the later versions had, the production version had Pratt & Whitney engines. A painfully long development because not only did Northrop have to design the aircraft to fly by itself all those miles, it had a 5,000-mile range, one way, but it also had to be able to track the target, so it developed the Star Tracker system, which started essentially Northrop Electronics, which was a daylight star tracker. In other words, you had this thing on your aircraft and you could track your position by where the stars were in day and at night. So that really started a whole realm of sophisticated UAVs. Ryan, which is another Heritage Northrop company, and Radioplane, which is a third Heritage Northrop company, weren't the only ones doing UAV, guys. Northrop. As with anything, once you get a design going, you start playing with it to improve it. This was a subsonic design, N134, which was the big wing. And by big wing, it had a 71-foot span. You can see how much bigger that wing is compared to what the earlier drawing was. Also note the position of the pitot tube, which means that it was able to fly at much more level flight. The snarks tended to fly like this. So this is trying to address some of those problems. At the same time they're developing a subsonic snark, they're also looking at a supersonic intercontinental cruise missile. And this is the Boojum, the N-25B or the MX-775B. They originally looked very similar. I saw a drawing that was posted on not Secret Projects, but Designations website that showed a design very similar to the N-18. A little bit longer, but the same basic configuration. It eventually evolved into this highly swept design. Notice the very pointed wingtips. It went from having designs with the engines in the center or to being engines in the belly. Now you have two potted engines out on the wingtips. The engines in this particular version were short-life GE J47 turbojets. Short life means that they were only good for 25 hours. But your mission was only going to last about 4 hours anyway, so who cared? You know? You go up Mach 1.8, you know, that's going to be fine. So you notice in the drawing on the upper left, it had this expendable wing that it could carry out for a part of its cruise range, then it would drop the wing and then kick up to high supersonic speed and go in country. There were designs for it to launch from a B-36 or B-36 variants, including turboprop and turbojet. You can see some of the later versions or some of the later concepts for a intercontinental cruise missile. The top one, again, twin engine, basically a Delta. The drawing on the right shows one of the later configurations. It's a clip Delta, but it had expendable outer wing panels. You can see by the aircraft just below that one, it still has the wing panels on. Again, the same idea. It cruises out after launch to a specific target once it gets within like 1,500 miles of target, pops off the wing panels, increase your speed to Mach 1 or Mach 1.8 or Mach 2, and then go in country. They also looked at snark with side inlets. They were doing all sorts of designs. Now they had a supersonic snark because they realized that subsonic snarks could be intercepted a lot easier than a supersonic one. So they said, oh, well, let's just make it supersonic. Note that it now has a horizontal tail. You can see the drawing on the upper left. The N191 is interesting because the N191 was essentially another go at a supersonic interceptor. And in Mach 2.5 to Mach 3. So it was essentially a replacement for Navajo. Navajo had failed by this point. So this is the design iteration of the N191. You can see that it's got the twin pods outboard, very similar to the basic configuration of the N25B. Then they go, well, no, this isn't working, so we'll go with a single engine concept with a dorsal inlet, which is the drawing on the upper right. And then they said, no, that's not working either. Let's go with an annular inlet with engine in the body. So that's the lower two drawings. You can see the drawing on the lower right is the final configuration of the N191. And it was called Supersnark. The N217, I haven't been able to find an image of, but using basic logic, N217 isn't going to be the N25B Boojum. Boojum was banished because once Boojum was canceled, then Edgar Schmood came on. By the time this program comes on, Edgar Schmood had retired, so now you can use Boojum again. And what is a Boojum? A more dangerous form of snark. You can see the picture there of the Super Snark, which is essentially the last iteration that we saw on the previous slide. My guess is that Super Snark became Boojum again. After we lost Boojum, we sort of got out of the guided missile business until this guy. And that's when we started to incorporate LO technology into that. And long story, long sad story that many a Northrop person will weep tears over if you get them enough beers. But suffice it to say that when it worked really well. The problem was that little things kept causing problems, like inadequate bolts, or the fire plugs to blow off stuff wouldn't work, or it would hang up. So you had a lot of failures that are normal in the course of cruise missile technology, but should have been covered because the subcontractors were giving substandard stuff, which happens. So the upshot is the price for these fixed price missiles ballooned. When we went to renegotiate the Air Force, it was just now the end of the Cold War. The Defense Department, the Air Force, the Army, and the Navy withdrew, or the Army withdrew, the Navy and the Air Force couldn't swallow the pill, and so the program died. Supersonic evolution. The prime Air Force interceptor night fighter in the 1950s was the F-89 Scorpion, Northrop. They were originally gun nose versions. That was decided to be barely adequate or even inadequate, so they went with a missile-armed version, which became adequate. So Northrop decided to try to improve the performance. And one of the very first things they did, and this isn't from a 1949 brochure, the illustration on the upper left is a swept-wing Scorpion. But that wasn't the only thing they were looking at. They were looking at up-arming them because they decided that 620 millimeter cannon wasn't going to be sufficient to bring down bombers. So they designed heavier and faster, such as the drawing on the right, the F-89F. It had those mid-wing pods, which was unusual, but would show up on later designs. Each pod carried 640 gallons of fuel, plus a load of up to 112 folding fin aerial rockets, or a mix with 4 Falcon missiles. At the same time, the Air Force was also looking at a much improved interceptor and a much improved penetrator. This originally started off as a penetrator or an escort fighter. Escort fighters were becoming, with the Korean War, it was really realized that escort fighters weren't doing a darn bit of good, and the bombers were very susceptible if you flew them in mass formations against modern fighters. So that whole idea went out the window, but the Air Force did toy around with these ideas. So this started off as a penetrator and ended up as an interceptor. The N-53, you will note, used a lot of the same basic technology that was used on the N-25. Note the wing. Also note that in the drawing on the left, it's a prone pilot. They went to the seated pilot on the drawing on the right, but it still kept the basic Boojum layout. On another front, we were entering Navy contracts. So the early one, N-94, which was for a Navy day fighter, looked very much like the F-89F. The drawing on the upper left there shows the potted weapons and fuel things with the tail very similar to the later Scorpions. The Air Force also started looking at perimeter defense fighters, so that design evolved into the drawing on the lower right, which was the early N-126. Again, you can see elements of the Scorpion, very flat bottom because they moved the potted engines under the fuselage out to the mid-wing area. So that's basically moving things out. N-56 became the N-65. The Air Force said, okay, we're going with an interceptor. We want to do the 1954 interceptor. This will be the Wazoo interceptor. That'll take care of all of our problems. So Northrop came up with some designs, and some really strange designs too. Note the diamond wing. Note again, the diamond wing is on the upper left, the upper right. Again, an iteration very similar to the N-25 Boojum, but a manned version. A quick story about that. We did a new lobby at Space Park, and we were going to do something that showed Jack Northrop talking to a baby engineer, and the baby engineer having this crazy idea of something that would go into space. And we decided, okay, well, let's take something really futuristic looking like the N-25. And I said, put a canopy on them and put the rocket engines out on the tips, and that'll be really cool. And a few months later, I found this design. I said, oh, darn. Somebody had thought about putting a man in there already. The bottom drawings are interesting. The bottom right drawing is an unmanned interceptor controlled by what Northrop called Cybernor control. So even back in the early 50s, we were looking at unmanned, armed UAVs autonomous UAVs that would go out and shoot down enemy airplanes. The Navy version, this was our proposal. There were actually 4 different proposals. This is 3 of them because these cover the basic changes. You can see the top one does have remnants of the boojum wing, but they've kicked back the trailing edge to give more wing area. The bottom one is a delta, a mid-wing delta, and then the bottom one is a high-wing delta, very reminiscent of something that comes later. The Navy program dies, but the Air Force programs keep going. Now, these are later designs than the N102, which we'll talk about next time, but the drawing dates are earlier than Jack Northrop's retirement. So these were done under Jack Northrop's tenure, but were later given an N number under Edgar Schmood's tenure. Again, note the N25 basic configuration, but with a humongous vertical tail on the drawing on the upper left. And then, again, those armed booms, mid-wing booms on the drawing on the lower right. This was for interceptors. Again, you can see some more of the concepts. The N103 led to the N121, which was more delta wing designs, but more single man versus twin engine. And then the N32 was what they called a strategic fighter. Now, the drawing on the lower right is the N132 strategic fighter. You note that big dorsal pod on top of that. That was a 3,000-gallon conformal fuel tank. They also had one version with a 3,000-gallon conformal fuel tank on the bottom. So I'd hate to jettison that. Interesting designs. Well, that doesn't fly, but what does fly is the N126. We saw the early iteration that was very much like a Scorpion. Now we're moving into designs away from the Scorpions. These are Delta Scorpions. The first one, the N126, is the intermediate design. The drawing on the lower right is what the final configuration of the N126 was. The N126 very much reflects Edgar Schmood's design philosophy at this point. This is about 1953-54. Edgar Schmood was very enamored of podded engines for a couple of reasons. One was maintainability. You could swap out the engines. You could upgrade the engines relatively easy without messing with the basic airframe. It also allowed you to do other things and get more power. The problem is that huge problems with asymmetric thrust if you should have an engine out during takeoff or landing, or anywhere actually, but especially during takeoff and landing. So those were the drawbacks. So then this is the basis for what you see evolving. This was for the long-range interceptor program. The N126 was the optimized design. The N144, which is the drawing on the right, was the all-out performance entry. It was a massive interceptor. It was 103 feet long with a 78, almost a 79-foot span, powered by 4 Wright J67 engines. Top speed was Mach 2.04 at 40,000 feet. Its combat ceiling was 60,000 feet, and it could carry up to 48 folding fin aerial rockets, 8 Falcons, or 6 Ding-Dong missiles. Ding-Dong missiles were the name for what became the MB-1 Genie nuclear-tipped air-to-air missile. This sucker could carry 6 Genies. This was the top-end version. The drawing on the lower right was the low-end version, the N149. It did not meet hardly any of the requirements, whereas the N144 met all the requirements, but boy, what an expensive thing that would have been. The N144 was ranked first overall by the Air Force, but not by AMC, the Air Material Command. They ranked it like 4th or 7th for maintainability. But the rest of the Air Force thought, this hot dog, this guy's a winner. So Northrop gets to go on to the next phase. This is the time that you see the design revolution in the mid-1950s. You've gone from the podded engines, now you're to a T-tail design. This reflects what goes on with the N156 and the big argument between Edgar Schmood and Welko Gassich. Gassich and his team convinced that for the N156, the podded engines would not give the performance they needed, so they went to engines in the fuselage with a T-tail. This is reflected in the N167, which is the drawing on the upper left. Then they discover Very rapidly, because of other T-tail designs in service, you have severe pitch-up problems with this design, so you need to do something. So what they did is they extend the fuselage, drop the horizontals from the tail to the fuselage, and that gives you the N167A. Note the size of those horizontal tails. They're almost as big as the wing. Well, we don't win that design. North American wins that design with what became the XF-108, and they didn't get to build it either. But we did use those basic designs for other things. That early potted engine design on the upper left becomes a Navy project, a Navy fighter interceptor. The one on the lower right is an export day fighter looking very similar to what the N167 looked like, the T-tailed. This is also reflected in medium-range interceptors. At one point, the Air Force said, we can't afford a long-range interceptor, then some people were saying, well, let's go with a medium-range interceptor. And so we come out with the T-tail, because that's the time frame in which it came out. And they said, oh, no. T-tails pitch up, let's go with the horizontals on the fuselage, and then you get the N176, which is the illustration on the lower left. Note that the N176 looks suspiciously like a T-38 on steroids. This is an interesting design, twin nozzles, but it's an 8-engined aircraft. It had 4 J-85s in pods, 2 sets of pods. So you had 8 J-85s. The pilot had 2 throttles for the engines, so 1 throttle controlled 4 engines. 2 inlets, 4 engines on each inlet, and 2 exhausts. And they said, well, that's complicated. Let's go with a little one. Let's go with the N184, which is on the lower right. That only had 1 complex of 4 engines, so it was cheaper. Didn't have as much range. And that is the end of part 1. If you want to see the stirring conclusion, we'll come back and talk about this. Okay, we have time for some questions. The question was, how do you spell Boojum and where did it come from? And the answer is, Boojum was from a Lewis Carroll poem called The Hunting of the Snark. And Jack Northrop was very enamored of Lewis Carroll. He named the N25A the Snark. And of course, the N25B was going to be more powerful and more deadly, so he named it the Boojum. And that's when the Air Force let you name your own airplanes. The question is, why a flying wing? Why no tail? Is that correct? Why no tail? Jack Northrop was always obsessive about reducing parasitic drag on aircraft. The less drag you have, the more efficient your airplane flies. Horizontal tails, vertical tails, fuselages, they all induce parasitic drag. You reduce that to a plan form of a pure wing, and you've reduced the parasitic drag to about as much as you can. So it makes your airplanes fly farther, carry a heavier payload, and look very elegant. Okay, and what is the second question? Why didn't they have wings that folded out in flight or something when needed? Well, remember, folding wings add a lot of weight and complexity to an aircraft. Navy aircraft have folding wings because they need the deck space to store the aircraft. And there are very strict guidelines on the type of fold and the space required that the aircraft have to fit within. Now, there are some designs that have been publicized about aircraft that can change their shapes, where the wings could extend out or et cetera like that. Again, you're looking at trade-offs between performance and complexity, maintainability, et cetera. The question is, there are a lot of designs, a lot of German designs from the late 1940s that seem to have influenced a lot of American and British and Soviet designs post-war. Was that intentional? Was there communication? The answer is yes. There was communication. The Air Force and the British and the Soviets captured as much German equipment as they could and brought them to their home countries for evaluation. A lot of documents were recovered by Army personnel and were brought over for study by American engineers. Some German scientists, Operation Paperclip, brought German scientists to the United States to incorporate them into the aerospace industry to get their ideas. Were all of the designs influenced by that? No. There were many indigenous American designs that had no bearing on what the Germans were doing. However, it doesn't hurt to read what the other guy's doing to see, why reinvent the wheel? If they found something that you haven't known about, it pays you to read what they were doing. At the same time, there's been a lot of talk going around about how, Jack Northrop got all his ideas from the Horton brothers. No. They're saying, the Horton 229 flew in December 1944, early 1945, and Northrop saw some flying wing designs at the company. He was obviously influenced by that. No, the N1M flew in 1940. They were building the B-35 during the war. The B-49, they had already decided to switch to jet engines in 1944. This predated all of the German data that we got. But I can say that Jack Northrop was very much his own guy, and he had a lot of designs, as did other American manufacturers. There's a lot of stuff coming out now, especially in model kits, that show some of the amazing diversity in aerospace design thinking from guys like Kelly Johnson and from Boeing and Lockheed and the other companies, Convair, Martin. There was a lot of innovative people out there. So did we get some technology from the Germans? Yeah, absolutely. We'd be silly not to. But did it drive our whole programs? No, not really. I mean, the Delta stuff, Alexander Lippisch came over and helped Convair, but a lot of that was Convair stuff too. The question is, how much automated flying controls were available for flying wings, or was it all pilot controlled? Is that correct? In the early 1940s, it was all pilot controlled, but by the time they were developing the big flying wings, Honeywell had come up with the E7 autopilot system that addressed the issues. So they could have had flying wings that were. General Cardenas noted that the airplane was neutral stability. It wasn't adverse and it wasn't positive. The addition of the Honeywell would have made it positive stability, which means you could point the airplane and it would stable out real quick. The neutral stability, you had problems with it not settling down, but it wouldn't deteriorate. So, yeah, Roy, you probably answer this better than I could. The question is, did I find any documentation that explained why the government asked all flying wings to be cut up? They didn't ask all flying wings to be cut up. They only asked most of them to be cut up. The two flying wings that were left, the YB-49 and the YRB-49, were still flying at Edwards when the order came down to cut up, and it didn't happen all at once. It came in piecemeal. So essentially from January 1949 to the end of 1950, you saw first, the XB-35s get chopped up because we won't need them. And then they said, we won't need the other planes, let's chop them up. And then so they did that. The reason that they did that is, remember that these airplanes were at Hawthorne Field and they weren't outfitted to fly. So there was nowhere for them to go. And Northrop needed the space. So what else were they going to do? But they did have two wings left until they had that taxi accident with Rush Lee and on the taxi or the runway at Edwards, where the nose gear shimmied and collapsed and the airplane burned up. So you lost one existent flying wing. The second flying wing, the YRB-49, went back to Northrop, to the Northrop, Ontario facility, where it sat until Jack Northrop retired and the new regime at Northrop came in and said, we don't want anything to do with flying wings. Air Force, what do you want with this airplane? And the Air Force goes, well, we don't want it. Well, can we cut it up? Yeah, sure. They cut it up. There are two questions and I'm going to answer them. We'll have Roy, okay? Okay, the first question was, what did Jack Northrop do to finance the company with all of these years of R&D? What was going on that allowed the company to survive? I assume you're referring to Northrop Aircraft, Inc., the 1939 company? Okay, not the earlier companies that... Okay. For Northrop Aircraft, Inc., they were very shrewd about this, and Lamont Cohue was very, very adamant that Northrop become a subcontractor. So during World War II, while they were doing all of this R&D, which they got some money to do some of the R&D, they were building P-61s, which were ours. They were building N3PBs, which were ours. But we were also building empennages for Consolidated for their PBY Catalina. We were also building engine nacelles and engine cowlings for the B-17 for Boeing. Huge, huge, huge lots of work for that. Post-war, we did a lot of conversion of C-54s and C-47s into commercial airliners, retrofitting them back or converting them to passenger airliners. We also tried to diversify. I'm sure you've heard of the infamous Salisbury motor scooter, which is one of the things that Northrop tried to do. So there were a variety of things that kept the company afloat. We also had the YC-125 contract for a while. The Flying Wing was supposed to have a contract. So that money kept it going into the 50s. In the 1950s, it was Snark and F-89. After the 1950s, it was T-38 F-5. So there was always a source of income for the company, especially when they started doing 747 fuselages. So there was always an income for the company. The second question, and then we'll bring up Roy, is why haven't we seen a wider adoption of flying wings? Especially in commercial and stuff like that. There is an inherent reticence among both military and commercial operators to do something radical. So a flying wing, while it looks great and the Air Force has proven that it does work, nobody has decided that they're going to be the first one to fly an airliner with that. Now, having said that, both McDonnell Douglas and now Boeing, which bought McDonnell Douglas, have been pushing very, very hard on their blended wing body designs, which is very similar to some of the early Northrop blended wing designs, the wing body designs that we saw. Flying wings are becoming more and more accepted, especially in unmanned vehicles. I think you will eventually see more manned vehicles, commercial vehicles with flying wings, but it's going to take a little more time because people are cautious. And with that, I want to bring up Roy Martin, who's a former test pilot for the Northrop Corporation and Northrop Grumman.
Hey, Tony, thanks. Not here to steal your thunder, but you and I have had great relationship at Northrop over the years. Fantastic work, fantastic research. You're awesome. Thank you. And thank you for doing this effort, putting together this historic effort project on the designs of Northrop. Appreciate it. Now, the question was stability of the flying wing and what was the evolution, essentially, of the autopilot control of the airplane. Like, what's the difference between a YP-49 and a B-2, and essentially the electronic flight control system of the B-2 makes it a super stable platform and an excellent bombing platform. But it wasn't so, according to my discussions with General Cardenas. My discussions come as a part of the Society of Experimental Test Pilots, where we get together among the test pilots and talk about a lot of the older projects and the problems the guys had, so that we can pass that information to the younger pilots. So, as I was discussing with General Cardenas one day on the YB-49, he made a statement that he was assigned, and again I'll paraphrase his statement, that he was assigned as a project pilot on the YB-49, and he was tasked by, and I believe it was Colonel Boyd, it might have been General Boyd at the time, to do a evaluation of the bombing platform of the YB-49 for its acceptability as an Air Force bomber. And the YB-49 had a residual problem with essentially a lightly damped Dutch roll. So he said that by itself was not so much the issue, but the Norden bomb sight was the bomb sight that they were trying to use on the YB-49 platform. And that the Norden bomb sight required a fairly stable platform to get the accurate bombing that it was known for. But the YB-49 didn't have that degree of accuracy, so that combination, he said, caused them to spread a lot of bombs around the Edwards bombing range, to paraphrase him. And therefore, he had to come back in front of a group that included Jack Northrop and some of his staff, and I'll say General Boyd and his staff, and give his evaluation. And he, Major Cardenas, had to declare the YB-49 at that time as unacceptable as a U.S. Air Force bombing platform. for an aircraft for that. And in that meeting, he said he remembered that General Boyd then turned to Jack Northrop and said, well, sir, what do you think? And Jack Northrop said, well, sir, if we got a problem, we're going to fix it. And on the staff of General Boyd was one of his staff officers, a captain in the back, who made a kind of a comment, how you going to fix what's impossible to fix? And Jack Northrop, it said, without taking his eyes off of General Boyd, said, sir, I can't believe you have on your staff an officer who thinks that the impossible is really impossible. So I thought that was kind of a characterization of Jack Northrop. It was pretty cool. But the story goes on, because Major Cardenas was then tasked to take the airplane to Andrews Air Force Base to set static display for an air show back in the Washington, D.C. area. So he's got the airplane on display at Andrews, and trooping down the line is President Truman. And he said President Truman walked up to the airplane and instantly fell in love. And he told Major Cardenas, Major, I want you to take this airplane, fly over the White House down Pennsylvania Avenue, and fly over the Capitol, and show Congress the next airplane they're going to buy. And he had just declared this as an unacceptable bombing platform. But dutifully doing as he said that he had to do, he took off and was coming in from the west, and he was trying to find the White House, and he said there's kind of a high rise to the west of the White House, and you don't really see it when you're coming in fairly low altitude until you're right on top of the White House, and there you go. He kind of elaborated that he thought maybe that had some indications on 9/11, because he said what is dominant when you're coming in is over here is this big building called the Pentagon, and that would be a great alternate target if you couldn't find the White House on that day. But on his case, he did find the White House and flew down Pennsylvania Avenue to show Congress the airplane that they were going to buy that he had just declared unacceptable. I thought it was a great story to share. But later on, to answer the question, yes, the stability of the B-2 makes it an excellent bombing platform, so the problem is moot to this day. Tony?
Yeah.
Thank you.
I have a follow-on to that story. When Cardenas flew the YB-49 down Pennsylvania and over the Capitol building, there was a tourist there taking pictures, and he looks up and he shoots the only pictures we have of the YB-49 over the Capitol building. He was so spooked by the idea that he shot some secret airplane that he voluntarily turned it into the Air Force and said, I'm really sorry I shot your secret airplane. Which leads me to the appearance of the B-2 at Hawthorne during one of the Hawthorne airfares. That B-2 made one pass and created 57 UFO calls to the local stations and 2 traffic accidents, because people could not believe what they were seeing. And that's the end of the program.
Thank you for watching Peninsula Seniors Out and About. I'm Betty Wheaton. See you next time.